You might be wondering, how fast did that guy hit that ball?
Right, so we can find the position of the particle, or in our case, the ball, by taking the integral of the velocity function, which is a piecewise function, which means that we are taking two separate integrals, and in order to take the integral, we find the antiderivative of each of the two functions, given our initial condition. To do that, we add 1 to the power of the variable, and we divide by the number that the power is. So in that case, 1 plus 1 is 2, so we divide the negative 9.8 by 2, and that becomes negative 4.9 t squared plus c. We can never forget the c. So the second half is the same thing.
And it becomes negative 4.9 t squared plus 14.629832 t plus c.
So now we can use our initial conditions for each of the two functions in order to find what our constant c is. So we plug in 0 for our time t, and we set it equal to 2.73 and solve for c. For our first half of the piecewise function, we get c equals 2.73, and now we set negative 4.9 t squared plus 14.629832 t plus c equal to 0, and we plug in 0.74642. And we get c equals negative 8.190. And now to write our final piecewise position function, we have p of t equals negative 4.9 t squared plus 2.73 and negative 4.9 t squared plus 14.629832 t minus 8.190. Now, our initial velocity function had parameters for each of these two functions, so those two parameters will stay with each of the two anti-derived functions. And this is how the speed of a ball is found in a bunch of pro leagues. Like my GOAT TJ DeFalco right there. And there. And there. And there. Well, technically it's found through the use of derivatives, which we'll get to next.
So when we're given the velocity function right here, and we need to find the acceleration of the volleyball as it's traveling through the air, what we need to do is we need to take the derivative of the velocity function. And since it's a piecewise function, we take it in parts. We look at this function right here. And to take the derivative, we multiply whatever the exponent is, bring it down, multiply this guy right here, and then we subtract the exponent by 1. So this gives us negative 9.8. Then we go on to the second part of the piecewise function, right here. Now, this one's a little different. This is a multiplication thing. So what we do is we don't take the derivative of this guy, and then we take the derivative of this, which returns to 1. And then we don't take the derivative of this, but then we take the derivative of this, and any constant, always, the derivative of that is always 0. So then in the end, this is our acceleration function right there.
This is how fast that guy hit that ball.